is on simplifying square roots. So your calculator will do this for you, but you need to understand why it is what it is, because you will have to turn in work for your credit on this one. So your calculator, if you put in your calculator the square root of 44, you would get 2 root 11. Like that's how it would come out. So to show you, let's see here. If I remember, it was 44. So we would do second x squared 44, and yours will come out that 2 root 11. So it also comes out as that decimal. But your calculator, we're going to learn how to get 2 and then the radical sign with 11. So let's talk about how that is going to happen. All right, so to simplify a square root, there's a couple ways you can do it. And the one would be, the first way I would tell you is to divide out a perfect square. And those of you who can see perfect squares, it's super great. But I'm actually going to show you the way I prefer, especially in the beginning when we're learning this. So I have listed all of our perfect squares right here up to 13. So if we know that we had like 2 times 64, we know that we could pull a perfect square out of that. But let's just start. Let's say that we have to find two numbers. You guys have done factor trees before, so that's what we're working on. So factor tree of 150. We could say, okay, well, I can do 10 times 15. So I would do root 10 times root 15. Now I notice that neither of those are up here. They're not a perfect square. So I need to keep breaking them down. And so I have root 2 times root 5. Now, not only are these not perfect squares, but they can't be broken down. So I'm done. So I'm going to actually, just like before, you would circle if they were prime, you'll circle those. And then I have root 3 times root 5. And again, these are prime. So then we could rewrite this. So we could take our radical sign, and underneath our radical, or underneath our root sign, we would write 2 times 3 times 5 times 5. Now here's the deal. Anytime a double shows up in here, they're a partner, they're a pair, so they're going to leave together, like almost like they're going on a date. So they leave, but they leave in one car. So we're going to pull a 5 out. Because right here, this 5 and 5 is actually 25. And so that's why we can pull it out, because it's a perfect root. I cannot pull out a 2 and I cannot pull out a 3 because I have to have 2 of them to pull them out. These are pairs. So this means I had a pair of 5s in there. So our end thing would be 5, which would stay there. And then inside, 2 times 3 would be 6. Now, this is the kind of work that I would expect you to show me. So then I could look and I'd say, just to show you, we have 150. So I'm going to plug it in here. Second x squared, 150, and we got 5 radical 6. If we go back to our notes here, we got 5 radical 6. Now, some of you could realize, well, I could have pulled out, like some of you may have done 25 times 6, and you would have realized that this is a perfect square. And so you could have done 5 radical 6, because 6 wouldn't break down into any other ones. The easiest way in the beginning is going to be just like this. Okay, so we're going to start with 50. And I'm going to break it down. And again, it doesn't matter. You could do 2 and 25 if you wanted. That's personally what I would do. But some of you will do 5 and 10. So I'm actually going to do 2 and 25. Now, I know that this is a perfect square. So I could be done. But to just show you, 2 doesn't break down, and 25 will break down to 5 times 5. So when we write this, we would have underneath our radical, or underneath our root, we'd have 2 times 5 times 5. I'm looking for pairs. Here's a pair. They can leave. So they're going to go in the car, leaving you with 5 root 2. And if you look, 25 was a perfect square, so that would have simplified to 5, leaving us just with that 2. All right, on number 12, we could do root 2 times root 6. Neither of these are perfect squares, so I'm going to circle 2, and I'm going to do radical 2 times radical or root. These ones are done now. So underneath here, I would have 2 times 2 times 3. I'm looking for pairs. I have a pair of 2's right here. So that would simplify to 2. So I'd end up with 2 radical 3. All right, pick any 2 on here to do. I personally would do radical 2 times root 100, or root 2 times root 100. And that's because I know that 100 is a perfect square. But this only helps if you know your perfect squares. But if not, we could still break this down. This would be 10 and 10. Well, there's a double right there. So I could pull those out, or you could keep going and you'd have 2 and 5 and then 2 and 5. So I'm going to show you, if you didn't know your perfect squares, how this one work. So underneath here, I'm going to have to write it down here too. I would have a 2, and a 2. So 2, 2, and 2. And then I had 2 5's right here. So these 2's would leave. They're a pair. I have a pair of 2's, and I have a pair of 5's. So when you pull these out, these get times together. So I was able to pull out a 5 and a 2, which is 10. And I'm left with 2 inside or underneath my root. Now, just to show you, I'm going to do root 200, or radical 200. And you'll notice we get the 10 outside and the 2 inside. And that's because we were able to pull a perfect square 25 out, which was 5, and a perfect square 4 out, which was 2. So we were able to pull out 10, and that left me, the only thing that was under there is 2. If there would be more things left under there, we would have multiplied them together as well. So let's try this next one. We could do root 9 times root 8. This would be radical 3, or root 3 times 3. And this one would be 2 times 4, which is 2 times 2. So again, looking at this, I have 2, 2, and 2. So I have 3 2's. 2 times 2 times 2. And then I have times 3 times 3. I'm looking for pairs. I have a pair of 2's. That gets pulled out. I have a pair of 3's. That gets pulled out and multiplied together, leaving me with 6. And underneath there, I just have radical 2. So the reason you need to understand that you're pulling pairs out is because not always will they be numbers. You may have some letters. So like on this one, this person started this, but they didn't pull out all of it. So your 5 is already out here. But this 20, we could simplify it down to 5 times 4 still. So root 5 times root 4. This root 4 still simplifies to 2 times root 2. Well, here's a pair of 2's right here. So they should have pulled that out. So really, we have 5, and then underneath the radical, we have 2 times 5. You can see this person didn't simplify because there's another set right there that needed to come out, leaving me with 5 times 2, which was 10, radical 5. So just to show you, if I put this in my calculator, I would have done 5 and, no, I can't remember, was it 10 in there? And 20. And 20 underneath there. And you'll notice I get 10 radical 5, which, if I put the right number in there, we should have gotten the same thing. So this person started, they just didn't finish. They didn't pull out all their perfect squares. All right, so now let's look at this one. This one, all we have to do on these is write this out. So this says x 6 times. So there's 1, 2, 3, 4, 5, 6. So there's x to the 6th power times this y. So now I'm looking for pairs. Well, there's a pair of x's. So I'm going to pull that one out. I'm going to times it by this pair of x's. Oh, and I have another pair of x's. So you're not going to write x times x times x on the outside. We're going to write, we had x to the 3rd power times root of y, whatever that y is. All right, try these two on your own, okay? So this 100, this should come out if you do, obviously you put it in your calculator, but I'm going to ask to see your work. And then this one, you can't put it in your calculator, so what would that look like?